In this question, you have to integrate sec square x upon 1 minus 10x. Actually, here we have the differentiation of 10x within the multiplication of dx. So, it is preferable that we have to assume 10x is equal to t. So, we can get sec square x dot dx is equal to dt. So, integration will become this sec square x dot dx will become dt and 1 upon 1 minus, instead of 10x we have to place t, so we'll get t square, which is in the form of 1 upon a square minus x square, where your a is 1 and x is t, and using second formula we can say its integration is simply 1 upon 2a log mod a plus x upon a minus x plus c. So here we'll get 1 upon 2 times 1 log mod 1 plus t upon 1 minus t plus c. Now, to get the final answer, we just have to place value of t, which we assume as 10x. So your answer will be 1 by 2 log 1 plus 10x upon 1 minus 10x, which is given in option D. Ta-da! In this question, you have to integrate 3x raised to 5 upon 1 plus x raised to 12. Actually, this x raised to 12 can be rewritten as x raised to 6 the whole square, and its differentiation is also available within the multiplication of dx. So, it is preferable that we have to assume x raised to 6 is equal to t. Differentiate both the sides, we will get 6x raised to 5 dot dx is equal to dt, but we have x raised to 5. Now, we have to move this constant term on the right side. So, it will become 1 by 6 dt. So, we can modify our integration as this 3 is constant, take it outside, integration of this x raised to 5 dot dx will become 1 upon 6 dot dt and 1 upon 1 plus t square. So, here we get 1 upon a square plus x square form, where your a is 1 and x is t. So, using third formula, we can say its integration is 1 upon a into tan inverse of x by a plus c. So, 3 by 6 is constant, we don't have to worry about it. Its integration will be 1 upon 1 tan inverse of t by 1 plus c. So, here we'll get 1 by 2 tan inverse of, instead of t, we have to place x raised to 6 plus c. Is your final answer, which is given in option D. Ta-da! In this question, we have to integrate 1 upon x square minus 10x plus 34, which is in the form of 1 upon ax square plus bx plus c, where your a, which is coefficient of x square, is 1, b, which is coefficient of x, is minus 10. So, we can get your last term using b square upon 4a, where your b is minus 10 and a is 1. So, you get 25 as your last term. Now, let's write down what we have. Now, we need 24 as your last term. So, we have to add and remove 24. So, as you can see, in first 3 terms, we will get perfect square, which is made by root of first term, sine of middle term, and root of last term. And these two constants will give us plus 9 dot dx. Now, to convert into standard form, we have to assume x minus 5 is equal to t. So we can get dx is equal to dt. So your integration is converted into this x minus 5 become t, so it will be t square plus we have 9 which is actually 3 square and dx will become dt. So here we get 1 upon x square plus a square form where your x is t and a is 3. Using third formula, we can say its integration is simply 1 upon a tan inverse of x by a plus c. So here we'll get 1 upon 3 tan inverse of t by 3 plus c. And to get the final answer, we just have to place the value of t, which we assume as x minus 5 plus c. So tada! In this question, we have 1 upon 4x square plus 12x plus 5, which is in the form of 1 upon ax square plus bx plus c. Now, here we have 4 as a coefficient of x, and I always prefer to get coefficient of x square as 1. So, let's take 4 common from the denominator. So, we will get x square plus 3x plus 5 by 4. Now, the coefficient of x square is 1. b, which is coefficient of x, is 3. And we can get required last term using b square upon 4a, where b is 3 and a is 1. So we will get 9 by 4 as your required term. Now let's write down what we have and add and remove the required last term. So we'll get plus 9 by 4 and minus 9 by 4. Now let's move to the next step, in which the first 3 terms will make perfect square by root of first term, sine of middle term and root of last term. Then minus 9 by 4 and plus 5 by 4 will give us minus 4 by 4, or we can say minus 1. To convert it to standard form, we have to assume this x plus 3 by 2 is equal to t. So here we'll get dx is equal to dt. So we can convert our integration in the form of t square minus 1 square, which is in the form of 1 upon x square minus a square, where x is t and a is 1. And using first formula, its integration can be 1 upon 2a log mod x minus a upon x plus a plus c. So, here we'll get 1 upon 2 times 1 and log mod t minus 1 upon t plus 1 plus c. This 4 into 2 will become 8, and to get the final answer, we have to replace your t by x plus 3 by 2 in numerator as well as in denominator, which can be further simplified into log mod 2x plus 1 and 2x plus 5 plus c. Tada! In this question, you have to integrate 1 upon 1 plus x minus x square, which is in the form of 1 upon ax square plus bx plus c, where your a, which is coefficient of x square, is 1, b, which is coefficient of x, is also 1, and we can get the required last term using b square upon 4a, where your b is 1 and a is minus 1. So we will get minus 1 by 4 as your required term. Let's write down what we have and then add and remove required last term. So minus 1 by 4 and then we have to take plus 1 by 4. So here this 1 plus 1 by 4 will become 5 by 4, and after taking minus common, this minus x square will become plus x square, plus x will become minus x, and minus 1 by 4 become plus 1 by 4. So as you can see, here 5 by 4 will be as it is, and this bracket is actually perfect square of root of first term, which is x, sine of middle term, and root of last term. So we complete our second step. Now to convert it into standard form, we have to assume our bracket is equal to t. So we will get dx is equal to dt. So our integration is converted into this 5 by 4 can be read as root 5 by 2 the whole square minus, now your bracket is t, so it will become t square dot dt. So here we get 1 upon a square minus x square form, where your a is root 5 by 2 and x is t. So using second formula, we can say its integration is simply 1 upon 2 times a log mod a plus x upon a minus x plus c. So here we get 1 upon 2 times root 5 by 2 log mod root 5 by 2 plus t upon root 5 by 2 minus t plus c. Now these two will cancel out. We will get 1 upon root 5, and after taking LCM we will get root 5 plus 2 times t upon root 5 minus 2 times t plus c. Now to get the final answer, we have to substitute the value of t, which we assume as x minus 1 by 2. So after simplification, you will get log mod root 5 minus 1 plus 2x upon root 5 plus 1 minus 2x plus c can be considered as your final answer. Ta-da! In this question, we have integration of 1 upon under root of 3x square plus 5x plus 7, which is in the form of 1 upon under root of ax square plus bx plus c. Before we start this up, normally I prefer that the coefficient of x square should be unity. So let's take 1 upon 3 common. So it will become under root of 3, and your denominator will become under root of x square plus 5 by 3x plus 7 by 3. Now, we have a is equal to coefficient of x square, which is 1, b, which is coefficient of x, is 5 by 3, and we can obtain our required last term using b square upon 4a, where your b is 5 by 3 and a is 1. So we will get 25 by 36 as your last term. So let's add and remove 25 by 36. So here we can say your first three terms will make perfect square, the root of first term, the sine of middle term, and root of last term, which is 5 by 4, and minus 25 by 36 and 7 by 3 will give us minus 59 by 36 dot dx. Now, let's move to the next step. To convert into standard form, we have to assume this bracket is equal to t. So we can get dx is equal to dt. So we can say our integration will be modified as bracket here, which we assume as t square minus this 59 by 36 square of root 59 by 6 dot dt, which is in the form of 1 upon under root of x square minus a square, where your x is t and a is root 5 by 6. And using fifth formula, we can say its integration is simply log mod x plus whatever you have in the denominator plus c. So here we'll get 1 by root 3 log mod t plus whatever you have in denominator plus c. Now, to get the final answer, we just have to substitute value of t, which we assume as x plus 5 by 4. So, and we'll get 59 by 36 plus c. After simplification, you will get 1 upon root 3 log mod x plus 5 by 4 plus under root of x square plus 5 by 3x plus 7 plus c as your final answer. Ta-da! In this question, we have integration of 1 upon under root of 16 minus 6x minus x square, which is in the form of 1 upon under root of ax square plus bx plus c, where a, which is coefficient of x square, is minus 1, b, which is coefficient of x, is minus 6, and we can get the last term using b square upon 4a to get the perfect square, where b is minus 6 and a is minus 1. So we will get minus 36 by 4 minus 9 as your required last term. Now, let's write down what we have. To make perfect square, we have to add and remove required last term, which is minus 9. So we have to add plus 9. So here we can say 16 plus 9 will give us 25, and after taking minus common, we will get x square plus 6x plus 9 dot dx, which is actually the perfect square of root of first term, which is x, sine of middle term, and root of last term. So here we complete our second step. In third step, to make standard form, we have to assume the bracket is equal to t. So we can get dx is equal to dt. So your integration is converted into this 25 is actually 5 square. Then we assume your bracket as t. So we'll get t square and dt. So here we get 1 upon under root of a square minus x square form. where your a is 5 and x is t. And using fourth formula, we can say its integration is simply sine inverse of x by a plus c. So here we'll get sine inverse of t by 5 plus c. Now to get final answer, we just have to substitute the value of t, which we assume as x plus 3. So tada! We get your final answer.